so you have a packet there, which will mimic your notebook once you get the notebook. And again, the notebook's going to look like this. You'll purchase this at some point between now and Friday of next week from West 211. And your notes are in there as well as the work. So I gave you basically the first 2 weeks worth. But a lot of times in here, we're going to do some notes, and then I'll say, on your whiteboard, try this. Now, it's on the whiteboard, try it, and if you get it right and you're like, that's something that's going to be helpful for me, then we will continue it. So we are starting out with working with integers, and the first thing talks about, says addition, right? Addition. What's addition? You plus it. Okay. You count it up. Add. Okay. So things that come with a plus sign mean on a number line, and you might remember the number line back in elementary school they had above the board. It's just moving to the right. Okay? So addition is the most basic. It's just a counting principle. Okay? You have 3 apples in this bag, and you have 4 apples in this bag. How many do you have? Well, you can count them up and go 1, 2, 3, 4, 5, 6, 7, or you can go 3 plus 4 to get 7. Okay? Now down at the very bottom of this says, same sign, sum, the values keep the same. Different signs, find the difference, and the sign is the same as the bigger number. Oh, why? That's a mouthful. Okay, so I'm going to try 2 examples. So if I do 4 plus 8, and if I want negative 4 plus negative 8, these are both the same distance from 0. Okay? So 4 plus 8, 12. We're good with that? Okay? Now think about what 4 plus 8 means. You go into a store, you reach in one pocket, you have $4. Yes? Sure. How about a pen? You got it. Yeah, if you ever need a pencil or pen or anything, they're in my top drawer. You're welcome to go in there. You're welcome. So 4 and 8. You go into the store, you reach in your pocket, you got $4. You put your backpack down, you open your backpack, and you got $8. So the 4 and the 8 is 12. So think about it as a money process. Now, when the negatives take place, if I proceed, if in front of my sign is a negative sign, that means I'm buying something. I go into a store, and I see something that costs $4. So I grab it, put it in my shopping cart or my basket or hold it. And then I walk around and I find something that costs $8, and I want both. Negative 12. I will owe negative 12. Okay? But the thing is, the distance from 0 to 12 is the same distance as from 0 to negative 12. So a lot of times with anything, with numbers, it's a distance away from something. Okay, now I want to do something with different signs. So this is kind of a different idea. What if I add negative 8 plus 2? Okay, now, before we don't have to write this down, let's just think about this. If the negative sign was prior to it, what do I say that means as far as in the store? Was it, I have $8 in my pocket, or there's something I want to buy that's $8? Something I want to buy that's $8. What would the 2 mean then? What I have in my pocket. So, my friends, you go to a store, you see something that costs $8, you want to buy it. You reach in your pocket and I have $2. Do you still owe money?
Yes.
How much?
$6.
6. So because you owe $6. Okay, so now let's think about this. You remember I had said before, this 12 is the same distance from 0 as this negative 12. They just go different directions. And that's kind of a weird, bigger idea. So I want us to kind of think what this really means. If I have 0 on a number line, 12 is over here, Negative 12 is over here. So this distance here and this distance here are the exact same distance. Okay? So that's imperative to know, especially when you're dealing with this type of situation. Okay? Why was this a negative answer? Because negative 8 would have fallen over here, a bigger distance away from 0 than 2. 2 fell right here. The distance from 0 to 2 is a smaller distance than negative 8 is from it. So that's why it's a negative answer. So if you look at the number, yeah, negative number, some people make the mistake saying a negative number is small. That's kind of incorrect terminology. A negative number is to the left of a starting point, and the starting point we know of is 0. Does anybody know? A little cross-curricular. This is bonus footage. Anyone want to know where the concept of 0, who came up with the concept of 0? Any thoughts? Yeah, hypothetically. Not me. Someone with the last name 0? Oh. That might be, but I'm not sure. The concept of 0, the concept of nothingness. What does that mean? Emptiness, okay. Yeah, the concept of 0 actually came from the ancient Mayans. Okay, a lot of people think that all numbers came from the Greeks and the Romans and so. No, ancient Mayans. Think about that. That's pretty cool. So a little cross-curricular thinking about, we are dealing with stuff that it didn't just come from one region of the world where they were like, oh, we're smart, we count. No, the summation of all the things that we've realized, this concept of nothingness, of 0, came from the ancient Mayans. I think that's just cheap trivia knowledge, but hey, it kind of keeps the thought process. Hey, but I just did this problem in which I got a negative answer, but what if I kind of change this a little bit, and let's say I'm just going to flip-flop it to this. So theoretically, I'm using the same numbers, but the 2 here is positive, the 2 here is negative. The 8 here is negative, the 8 here is positive. Okay, so let's think about this. So I wanted something that costed $8. I had $2 in my pocket, so I'm going to owe $6. Now this, using the same terminology, I want something that costs $2, and I have $8 in my pocket. So do you have enough to buy the item? Yeah. How much? What does this come out to? It's a positive 6. So it's just a 6. We don't have to write the positive sign with it. Okay. I mean, if I ever put a plus here, that's totally fine. Plus versus just a non-sign is going to be fine. Okay. Now, so this goes along with, says different signs, find the difference and take this difference of the bigger number, or take the sign as the bigger number. So negative 8 in the blue top right corner, this negative 8, it's a negative number. That means the 8 itself is a further distance from 0 than the negative 2 would be in this case. Okay? So we have numbers on one side of 0 and numbers on the other side of 0, and sometimes our result would come out as a negative answer, and sometimes our results would come out to be a positive answer. So why does one answer become positive, one become negative? You're talking about a distance. That's really all it is. Think about a distance. Think about where I'm standing right now. Is there a distance from me to you? And is that difference different with everybody in this classroom? I mean, the distance for you to I is different than this distance here. Or this distance here is different than this distance. We're talking about a direction. We're talking about negative or to the left of 0. Again, the concept of 0 comes from the ancient Mayans. I mean, this is just, math is a really beautiful thing, and it's a logical thing, and it's a progressive thing. And yeah, there's some math out there that's ridiculous where I can assure you there's math problems that I've come across in my lifetime, and it's like, crazy. But I can assure you, my friends, the struggles that you might have with math are the same as the struggles I had with math. I wasn't good. I was horrible at math when I was a kid. My mom was a math teacher, but she didn't know what she was talking about. Okay? But that's just kind of the thing. So you have to just realize, is it okay that we see something that is harder for us? Sure. It helps us think. And that's okay to think. I don't need something to tell me how to think. I sure and heck don't want somebody to tell me how to think, right? You got to think this way. No, I didn't think that way. Well, why not? I think that way. Well, you think that way. That's fine. That's the way you think. I don't think that way. You crazy thinking that way. There's all kinds of silly thoughts out there. We've seen some silly people. All right. I think we've chased addition around the tree enough. Let's move on. Subtraction. So the whole theory of I have something and somebody wants something. Now, the whole subtraction thing, we've been dealing with subtraction already with the addition. It's a negative sign. All subtraction is adding the opposite. Wait, what? Yeah. The minus sign, adding the opposite. So if I had 15 minus 10, that gives me an answer of 5. Now, I want you to think about this. What if I had negative 10 plus 15? The negative 10 plus 15, let's go through our example. We see something that costs $10. We buy it or want to buy it. We have $15 in our pocket. How much do we have left? 5. So both of these give me the exact same answer. These are identical problems to each other. It's just that we have a subtraction sign, and the subtraction sign is adding the opposite. That's different. Okay? And we're not trying to do this to be bad, but I want to do me a favor. On your whiteboards, I want you to try these problems for me real quick. Just try those problems. If you get it wrong, that's okay. We can erase it. No one's got to see it. Does anyone need a little more time, or you feel okay? You good? Look at your neighbor. Does it look like they need more time? Okay. Now, I see some of you have calculators, which is great. That's a wonderful tool. Just if you use the calculator, let's make sure your answer is the same as mine. Okay? Because sometimes we think we might have plugged it in right in a calculator, and the calculator is doing exactly what we tell it to do, which sometimes it might be the wrong thing. Now, with simple addition and simple subtraction, it should be fine. Sometimes when you start dealing with multiple signs, it gets goofy. So just verify we get the right. All right, so very first one. I walk into a store. I have $4 in my pocket. I see something that costs $8. What's the answer? -4. Agree? Okay. Problem number 2. I go into the store. I have $10 in my pocket. I see something that costs $6. +4. Next problem. I walk into a store. I have $15 in my pocket. I want to buy something that costs $20. -5. Very good. All right. So me re-emphasizing the exact same thought process. We've all gone into a store. Agreed? Has anyone not been in a store? Raise your hand. It's kind of like, is everyone ridden in a car? Nah, what's this car that you speak of?
I knew someone who's never been to a gas station because their parents had electric cars, so they only gone to electric cars.
I don't have to go to a gas station either. I have an electric car. And my charging station at home is free because I produce 130% of my electricity through solar. Yeah, you're with the green energy guy. All right, sorry, off task.
Sorry.
All right, I love it. Next one. I'm walking to the store with $5 in my pocket. I want to buy something that costs $2. What do you got? 3. I walk into a store. I see something that costs $8, but I have $7 in my pocket. What do we got? Last one. I walk into a store. I have $2. I see something that costs $2, but I have $10 in my pocket. Seems okay. Look at that. It wasn't hard to try it. But again, my friends, if you start using the terminology, which is, we could stay very consistent on it. It's a very real thing. And I know it's very simple going, well, of course, if I go in the store, if I don't have enough money to buy something, you could choose not to buy it, or you say, I want this, I need $4 more. Hey, Billy, give me $4. What do you mean? Okay. Multiplication. Multiplication is just used to add up fast. Do you know that your calculator does not know how to multiply? You're like, wait a minute, no, it's got times right here. Okay? Now, I want to explain myself on this. Now, I just made a statement saying that your calculator does not know how to multiply. I kid you not. You want to know what it does? Let's say we wanted to do 3 times 4. Now, is everyone okay that 3 times 4 is 12? This is what your calculator does. This is a group of 4, a group of 4, a group of 4, add it up. That's all it means. 3 groups of 4 added up. That's what your calculator knows to do. It doesn't know how to go 3 times. It doesn't understand. It says 3, oh, groups of 4. That's also 12. Your phone doesn't know how to multiply either. But I got a calculator on my phone. I know. But the times button, it doesn't understand times. It's grouping. I have 3 groups of this. I have 10 groups of this. That's how it works. It's kind of crazy when you think about it. It's like, whoa, wait a minute. This is making me sweat. So, now, multiplication, again, because you're going to use calculators, I'm not too worried that it's like, oh, I don't remember multiplication facts. Okay. But things that you need to know is if I want 10 times 2, I get 20. If I want negative 10 times 2, I get negative 20. So we have a negative that took place. If I want 10 times negative 2, I get negative 20 as well. Okay, so that's different than the addition, right? In this case, if I were to add these together, I'd get negative 8. If I were to add these together, I get positive 8. But the sign means something in that. And then if I want negative 10 times negative 2, I get negative times negative is positive. So you have to realize if I multiply 2 positive numbers, 2 numbers that don't have a number or a sign in front of it that I see, I get a positive. If I have the same sign, negative times negative, it gives me a positive. if I have alternating signs, one positive, one negative, and we're multiplying, it's going to give me a negative. Okay, let's try these real quick. On your whiteboards, please. Oh, did you need more time to write that? Okay.
It's like on your mark.
It's your choice.
Oh, okay.
Okay, but you writing on your whiteboard, it's probably perfect too. You know what happened with me in high school? I kid you not.
What?
Even middle school, I would like go through pencils and pens like crazy, write all this stuff down, and I never once went back to look at it. It's like, why are you taking all these notes? Well, because I'm taking these notes because I'll look at it later. I never did. And I made it to this day right now in front of you. So I don't know what happened. They might have said, let's get that guy out of here and kick me out. I don't know. So these are all multiplication, even though my dots are goofy. Just for you.
So sweet, so kind.
And just try these on your whiteboard. You get them wrong, who cares? Erase it. Just try it. I promise you we're not going to break anything if we try something. Y'all aren't doing anything wrong. This just looked like a comfortable place for me to straighten my back on. Deal? Does anyone need more time, or we seem good to go? Good in the hood? All right, 4 times 3, which is 4 groups of 3 added up, is? Wait a minute, mate. Why are you talking crazy, Stirrup? Because again, my friends, your calculators don't know how to multiply. And we got smartphones. They said it's smart, and it doesn't even know how to multiply? Something's wrong. What is negative 2 times 8? Or negative 2 groups of 8? I'm like, wait, that doesn't make sense. It is negative 16, very good. What about negative 3 times negative 2? Oh, careful. Negative times negative, positive 6. Good, yeah. So remember, the sign changes because you had the 2 negatives, okay? What about 5 times negative 3? Negative 15, absolutely correct. Negative 6 times negative 4 is positive 24. The sign changed. Negative 7 times negative 8. 56, and it's positive. Huh. Thanks for letting me straighten my back. It's crunched over too much. I don't think this is on the notes. I don't have square rooting. I do have square rooting. Oh, square roots and squaring. So let's have fun. You got a calculator right there. Do you feel comfortable squaring a number, which means I'm going to multiply a number times itself? Watch. What I want you to do, I'm going to write 92 squared, which is 92 times 92. Okay, I don't want you to tell me what the answer is, but on your calculator, just go 92 times 92 for me, please. $84.64?
Yeah.
Okay, don't tell me the answer here. 93 times 93. The first one was 92. 93 times 93. Don't tell me what the answer is. Just go 93 times 93. $86.49? Woohoo! It's so simple. Watch this. Okay. So 92 is 8 away from 100, yeah? 8 squared is 64. That's the last two digits of the number. Subtract 8 from the 92, and you get 86. Don't worry if you didn't catch it. It's kind of a math, dorky, geeky, I'm weird, laugh when people fall type of thing. So square roots and squaring. Okay, so if I go, and you can write this down on your notes, 1 times 1, 2 times 2, 3 times 3, 4 times 4. It's up to you. You heard my whole story on taking notes when I was in high school. I never once went back and looked at them. But yet, I got to this point right here in front of you.
Whereas I'm the opposite, I have to write down everything or I forget it.
Well, I wrote everything down. I just never went back to it. I was like, what do I got this for?
Well, and then final.
1 times 1, help me out. 2 times 2. 3 times 3. 4 times 4. 5 times 5. 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10 is 100. 11 times 11. 121. 12 times 12. 144. Okay. So friends, we will say, hey, you have to know the first 12. But guess what? You got to use a calculator. You don't know how to get to them, right? A square, a perfect square, is I take the number times itself. So every number has a square. I can square any number. I could take 525. Well, if I wanted to square 525, I have to go 525 times 525, and I get a big old huge number. Sound good? Square roots is going from the green back to the black. So if I took the square root of 1, I would get 1. If I took the square root of 4, I get 2. If I took the square root of 9, I get 3. If I take the square root of 16, I get 4, so on and so forth. So squaring and square rooting, they're opposite operations of each other. Okay? So that's a little different to think about. Huh. Don't worry, you don't have to know this dorky math game. But does anyone want to see one real quick? 105 squared, it's 105 times 105. 105 is how far away from 25, or 105 is how far from 100? 5. 5 times 5 is? So 5 is that far away from 100, so I'm going to 5 away from 100, so because I'm above 100, I'm going to add 5 to 105, and I get 110.25. Am I right? I don't have the calculator.
Oh, wait, what is it? I know, I was doing the same thing. I was like, wait a second.
Yeah, you're right.
Yeah, buddy.
Can you do that again?
Okay.
So what's the strategy?
Okay, so this is basically how it works. It's a distance away from 100 is all you worry about. If you're above 100, you add that distance to the number and you square. So this is 5 away from 100, right? 5 times 5, 25. I'm 5 above 100. I'm going to add 5 to 105, 110. But let's go the opposite way. If I want to do 95 squared, that's also 5 away from 100, right? So 5 times 5 is 25. Because I'm below 100, I'm going to subtract the 5. So 95 minus 5, 90. Huh. It's kind of fun. We can have fun with math. It's not a horrible thing. It's something I was scared to death of as a kid. I'm still scared of it, but I'm taking on the beast. Math. I got it. It's me. Okay. Greater than or less than? Ooh. Bigger or smaller? Hey, friends, which one's the bigger number, just logically? 15. Okay? Now, when I was in elementary school, they'd say, Yeah, realize the alligator is eating the bigger number. Grew up in Arizona, we didn't have alligators. I don't know what the heck that is. Could have been like a rattlesnake eating the big number. No, it looks like alligator teeth. Darn teachers from back east when I was in Arizona. All right, what about this one? What's bigger? Agree? What about this one? Oh, they're both negative. Which is the bigger number? Negative 10. I would rather, so this is how I make it work in Stirp's head. It might work in your head too. Negative 10, negative 15. Would you rather owe somebody $10 or $15? Yeah, I'd rather owe zero, but if I were to borrow money, I'd rather only have to pay $10 back than 15. So that's the bigger number that way. Oops, I kind of went over my negative sign. I'm sorry. Okay. And then if it's equal, okay, duh. Equal shouldn't be too bad. I don't know if we have anything more. I think I'm done. Am I done? All right. Hey, do you guys want a lot of homework tonight? Whole bunch? Yeah. Make us cry. Okay, I'll tell you what. So the page number, page 3 and 4, you can see the page number at the bottom of your sheet. Okay? Now, this is where you have to use a little logic. All I want you to do is I want you to try the left column. If you don't know what the left column is, just do all the problems, and I guarantee you're going to get it. I'm kidding. No, the left column is 1, 4, 7, 10, 13, 16, 19, 22, 25. Okay? It's just down the left side. And then you flip the page over. It keeps going with 28, 31, 34, 37, 40, 43, and 46. So left column. Does that make sense? So that means there's a middle column and there's a right column as well. All you have to do in order to get 4 total points on this homework assignment is I need you to have tried all of those problems. If you tried it, does that mean they're always right? No. Is it okay that we make a mistake or 2 or 3 or 20 or 100 or 1,000? Absolutely. We're learning. Talk to me. A lot of them you don't, right? So just do the best you can without having to show any work. Okay? And heck yeah, I bust out a calculator and make sure tomorrow we'll go over the answers that your answers match, if you're using a calculator, match what I say. Because either I'm wrong or the calculator is wrong. All right, I guess it's both. Hey, did I teach okay today? Yeah. Why don't you take a little time to do this? And I'm going to say, yeah.